All right, welcome back. So this one is all about functions. We're going to briefly chat about evaluating functions. We'll talk about combining functions. Those things I'm confident you've dealt with before, and then we'll talk about composite functions or composite functions. Those you also probably have done at some point. Just want to make sure we're on the same page with notation. You'll see some of this notation pop up on Delta Math. Some of you will have already done this. In that case, 2 times speed this through this video. Though there is one evaluating functions example that I want all of you to watch because you'll be dealing with that one next week. Okay, first one here. If I gave you something like this, f of 3a, okay, and here's the function we're going to be dealing with here. F of x equals x squared plus 7. If I said, hey, could you please find f of 3a? Well, whatever's inside those parentheses, I'm going to plug in everywhere I see x. So 3a squared plus 7. I'd like to simplify that a little bit. What is 3a squared? You would end up getting 9a squared plus 7. That's what we're looking for there, okay? What if I asked you for f of b minus 1? Again, whatever I see in my parentheses, I'm plugging in everywhere I see x. So b minus 1 squared plus 7, right? So this is my original function. I plugged in b minus 1. I'd like to simplify this one a little bit. So b minus 1 squared, I'm going to have to do a bit of foiling, which will give me b squared minus b plus 1 plus 7. Let's combine up our like terms. B squared minus 2b plus 8. All right, that is f of b minus 1. Here's the one, I'm going to star this one, that I want all of you to watch, even if you're skipping through parts of this video. F of x plus delta x, ooh, that's new, minus f of x all over delta x. You may or may not have seen this delta symbol before. Delta basically means change in. If you've taken physics, you've seen delta for sure. Change in something, maybe you've seen it as like delta y over delta x, like change in y over change in x, rise over run, something like that. Maybe you've seen this in other math classes. In this case, it just means a tiny little bit of x, a little tiny change in x. We're going to deal with this a lot once we get into limits next week in actual calculus, and I'm excited for that. Okay, do what we've been doing. If I'm asking you to evaluate this, it means, okay, start with this one. I need to plug x plus delta x in for x in my original function. So that would look like x plus delta x squared plus 7. Okay, but then I still need to minus f of x, all right? So minus, I'm going to put this whole thing in parentheses. Be careful with signs. X squared plus 7. That's just f of x. And then they told us to put all of this over delta x. Okay, you got to stick with me here. We have to do some simplification. I need to FOIL out this x plus delta x times x plus delta x plus 7, and then distribute that negative, minus x squared minus 7 all over delta x. Okay, let's go ahead and cancel out those 7. 7 minus 7, get them out of here. And then we need to FOIL. So I'm going to end up with x times x, that's x squared. And then I have x times delta x. Delta x is a separate entity here, okay? So keep those as 2 separate things. That's literally going to be x times delta x. My inside terms, again, okay, that's x times delta x, great. And then my last terms, I have delta x times delta x, otherwise known as delta x squared. And then I still have this minus x squared term over here. All of this is divided by delta x. Okay, we're going to take this up over here. I need some more space. Combine any like terms. I see that I have x squared minus x squared. Those cancel. I see that I have x delta x and x delta x. I can add those to get 2x delta x plus delta x squared. That's all over delta x. I could simplify a little bit more, okay? I have a delta x in all of these terms, or you could think about factoring out a delta x up top. Oh, pencil. If I factor out a delta x up top, I'd be left with 2x plus delta x in parentheses. I can cancel out that delta x on top and bottom, and you are left with 2x plus delta x. And that is equivalent to this original thing that we started with, okay? If you are like, whoa, Miss Curlin, what? That is okay. I don't need you to look at this expression right now and be like, yes, this makes perfect sense to me. But I want to show you that even if it's something that doesn't make tons of sense right now, you already have the tools to plug everything in over here. You know how to plug stuff into functions. And then all of this stuff, we're just simplifying, okay? So you have those building blocks. What we're going to get to do in the next couple of weeks is see how this equation is very much a building block of all of calculus, okay? So get excited for that. If this example was like, wow, okay, haha, that was a lot, that's all right, okay? We're going to have plenty of time to go over these. Okay, so that's evaluating functions. Let's get into combining functions. So it's some of the typical ways that you would think to combine functions. You could add them. It could just be a sum. You could do a difference of functions, subtract them. You could have a product, multiply them. You could have a quotient, divide them. Some of these you'll be able to simplify, some you won't. I'm going to say let's use f of x equals 2x minus 3 and g of x equals x squared plus 1. If you were to add those, you would have f plus g of x. That's one way you could write it out. And you would just add them. Plus x squared plus 1. Okay, I guess officially I didn't have to put the parentheses there, but just to kind of show you, okay, you're adding these two separate pieces. You would have x squared plus 2x, and then combine your like terms here, negative 3 and 1 would give you minus 2. All right, so that's your sum of functions. You could also subtract functions. In this case, that would be 2x minus 3 minus x squared plus 1. I want to make sure to distribute that negative sign. So 2x minus 3 minus x squared minus 1. Okay, this one will look a little bit different for us. Some different signs. I'll end up with negative x squared plus 2x minus 4. Beautiful. All right, for your product. And here I want to be careful with this. I'm just using a dot here. We've used dots to represent multiplication. If you see something that's like a circle, that means something different. We're going to talk about that when we get to composite functions. If you just see a dot, it means multiply them. So what's 2x minus 3 times x squared plus 1? I'm going to have to do a little bit of foiling here. So I get 2x cubed plus 2x minus 3x squared minus 3. Just rewriting them in order of degrees would give me 2x cubed minus 3x squared plus 2x minus 3. And then for your quotient, honestly, we can't really simplify this one. You would have to just leave it as 2x minus 3 over x squared plus 1. Okay, here's the real meat of what I wanted us to talk about, composite functions. So anytime you see something in this format, f and then this circle, g, it kind of looks like just fog. That means f of g of x. So let's do an example to see what this would actually look like. For this, I'm going to give you f of x equals the same thing as before, 2x minus 3. But I'm going to say that g of x equals cosine of x, okay? And yes, trig is a big part of calculus. You will have lots of trig. If they ask you for something like this, f of g of x, it means find g of x, plug all of g of x in for x in your outside function. So 2, and then plug g of x in, 2 cosine x minus 3. If they did it the other way, g of f of x, that's the same as saying g of f of x. Well, you're going to take your whole f of x function and plug it in where you see x in your g of x function. So that would be, there's g of x, and then I'm going to plug in 2x minus 3 in for cosine of x. Okay? So for these, always start by finding your inside function And then whatever you're getting for that, plug it in for x in your outside function. And that's basically all there is to it. You'll have more practice on that with delta math. Continue working on your delta math if you have any questions. Number one, you must, to let me know that you read the assignment, submit it and add a comment or question that you might have tomorrow. We will make sure to go over those tomorrow. All right. Good luck.